Okay, Assalamualaikum and a very good day to all. Okay, so for today we're going to cover about the friction chapter. So I hope you have already learned about the previous chapter, which is the structure analysis. So for today's friction, you will learn about what is the friction actually, and then what is the mechanism and the fundamental knowledge about the friction, as well as all about the questions, for example, friction versus force, applied force, and then also whether the object is in impending motion or not, or slipping or not, or tipping or not. Okay, that is kind of thing that we got to learn about today's lecture. So friction is actually a resistance. Okay, a resistance force, okay, preventing, okay, or resisting a body from moving, actually from moving or slipping. Okay, moving or slipping. Okay, similar principle when you have your hands just like this, and then when you try to do some shaking like this, you have a friction from your hand, and then this one hits. Okay, say for example, the force preventing a resisting body from moving and slipping means that any kind of force which applied on a body, then that force is intending to move or change the condition for the previous condition. For example, in this case, the box is in static, it's not moving. When you apply force, then there will be a resistance. Basically, it's that action and reaction force, where you have the force, applied force, which is the action force, and then reaction force, which is the resistance force that come to resist the force that you applied, preventing the object from moving. Okay, so the keyword for friction is that you need to have contact surface. Okay, contact surface. Any kind of friction requires a contact surface. Two dissimilar object or two similar objects, is either one. Okay, and then also you have to relate with the action force versus reaction versus normal force. Okay, because friction force relies on the normal force. So normal force came from the weight which applied from the body, from the center of the gravity, from the center of the body itself, apply weight. So this normal force is actually the force which is acting perpendicularly, okay, towards the contact surface. For example, this is a two object contact surface. One you have floor, and then another one you have the box, for example. Over here you have the contact surface, so the normal the weight is over here based on the center of gravity. So here is the weight, and then here will be the normal force, and okay, which is need to be perpendicular, which is 90 degrees from the contact surface. So when you apply load, apply the weight, then you can have the contact surface over here, and then you have the normal force. So basically, if the weight is actually towards the gravity direction G, okay, you can get the exact similar weight over here, okay, for the normal force. So if the weight is 100 Newton, so does the normal force, which is 100 Newton. Okay, so the reason this normal force is very important, whenever you have a heavy weight, okay, you have a heavy weight on this box, so the reaction force must be much more is parallel, which is similar as this one, and then the resistance for this body to move is become much more bigger. That means the friction force will increase with the increase of the normal force. So you must know the action and normal force. So action force will be two different things. Okay, some may came from the weight itself. Okay, for example, if you have an inclined surface, another one when you have applied force over here. Okay, so you have two type of applied force. One is from gravity, from the weight. If you have an inclined surface, another one is the applied load over here. Okay, so of course, over here, normal force need to be related with the friction force. Okay, to understand this one, you need to have a proper diagram to explain about the friction force. Say example, you have a crate over here. Okay, then you have a contact surface of a floor over here. Then you have a load which is applied either horizontally or vertically. So this force over here, P, applied load. Okay, and then here is the height which this force is applied. And then right in the middle, which is the center of gravity of this object, of this crate, which is in the center. Assuming that this crate is uniform, then you can have the center of gravity right in the middle. So the weight is W. Now, over here, you will have extrapolation of the gravity line. Okay, sorry, the center of gravity line. And then over here, you have a normal force over here, N. Okay, which is 90 degrees towards the contact surface. And then over here, you will have the friction force over here. So friction force is F up. Okay, friction force. So this friction force is actually can be derived as mu times N. Mu is the coefficient friction. Coefficient friction means that you need to know the relationship between the applied force, okay, and the normal force. So which one much more bigger? If the if the mu value is lesser than 1, for example, that means you can have, okay, a very smooth surface. You can you can consider this one as a smooth surface. If you have mu much more bigger than 1, then you can have a lot of friction. For example, in the badminton court, you have a rubbery type of floor mat, for example. Then where you actually do some skidding to catch a ball, for example, to take a ball, for example, then you can have a nice grip. So this one is having a mu which is over 1. So mu is actually dimensionless. Okay, the reason why, and I will explain it to the question part later. Say for over here, okay, here you have distance, height h over here. Then here is the distance in between. Then we have here is a divided by 2. So a divided by 2 is actually the center of this one. Okay, and then when you have this F over here, which is equivalent to P over here, okay, whenever you have the force, applied force P, which is equivalent to P, sorry, the applied force P, which is equivalent to F, okay, then this one should be considered as an equilibrium. Equilibrium means it's still not moving until up a certain point when you have a maximum force, friction force over here. You see, when you apply force, you apply load over here, and then depending on the load over here, the force load over here should be equivalent to this friction force. As the force here increase, this also will be increased up until a certain limit when you have the Fmax, maximum friction force. So whenever you exceed this maximum friction force, you have Fmax is over here, okay, which is equivalent to P. In this state, we call it as an impending motion, before and after movement. Then when you exceed this value, okay, when you exceed this value, means that P is much more bigger than friction force, maximum friction force, then you can have a slipping. Okay, so you have two different type of coefficient friction. One is static, so you can have mu s, coefficient friction, okay, coefficient static friction. Another one, you have kinetic. Here is coefficient static, okay, coefficient static friction. Another one is mu at k, which is coefficient kinetic friction. Kinetic friction. Okay. Usually, the kinetic friction much more smaller compared to static friction. Okay, static coefficient friction. So these two are different. So I'm going to pause a bit. Okay, we continue about this one. Now look in this force versus sorry, the friction force versus the applied load profile over here. As you can see over here. Okay, here is the object. Okay, here is the weight over here in Newton. Remember, here is the load P, and then you have a friction force over here, and then here is the normal force over here. Okay, right now, when you see over here, when you increase the load T over here, okay, you can find out that the friction force, which is in parallel with the applied load. Okay, so of course in this graph you can have here is approximately 45 degrees. Okay, so the force, friction force versus the applied load should be consistently in parallel together. But up until a certain point over here, okay, where you can have, okay, over here static friction over here, Fs, which is the maximum value, and then here will be the kinetic friction. Okay, so over here, as you can see, as the P load increase, so as the force, friction force over here, then up until maximum over here, where you can have in this point over here, which is in condition, which is the impending motion, okay, or slipping and so on, impending motion. Then the friction force suddenly reduce towards the kinetic friction. So the reason why you have a static friction is much more bigger than the kinetic friction is that because of the coefficient static friction. So over here, the coefficient static friction, which is Ms, and here you can have Mk, Μk, sorry. So this mu s is much more bigger compared to mu k. So that's why you can have a lower friction force over here. Then if you imagine the force required for you to overcome the resistance of an object in static is much more bigger compared to the force that you are required to apply on a moving object. So moving object is already in motion, so the friction is already should be less. So that's why you can have the kinetic friction, which having much more lower value compared to the static friction. So over here, at this point, this friction, okay, static friction, which is considered as the maximum Fmax, which is equivalent to Fs. Okay. static friction, which is the maximum friction force of soil. As long as the load, applied load increase above this value, then you can have a slipping. Then after that, you can go for the kinetic friction. So the keyword important keyword for you to understand is that you can have the impending motion. So that means in the question it will ask you, it will state to you whether this body, okay, this object is in impending motion or not. Okay, so there are keywords lah. So either impending motion and another one is impending tipping. So okay, either this one is tipping or not. So about the coefficient static friction over here, okay, remember in this static that we have taken is the dry friction, okay, dry friction. If you go for the wet friction, then you can try to go for the mechanical engineering courses, then you can learn about the wet friction. So static friction is basically without any fluid or lubricant. Okay, mostly in the wet friction you can learn it in the engine and automobile and so on lah. That kind of courses. Okay. Say for example over here, you have an object over here. Okay. Okay, say for example you have over here is an object on the surface with a kinetic friction, vertical coefficient friction, which is S, and then the normal force is N, which is opposite direction to the weight, and then you have P, which is the applied load. So over here, okay, when you have these two forces over here, one is friction force, another one is normal force, then you can have a resultant force over here. Okay, so this resultant force is Rs. Okay, so Rs over here. So the addition of these two vectors over here, okay, assuming that this one you have a vector over here, you should know that Rs, which is equivalent to resultant force. S means static, which is equivalent to normal vector plus friction force vector. Okay, so eventually then you can get an angle over here, which is psi S over here. Okay, now over here, if you use tangent psi S over here, you should get, okay, tangent which is over here divided by over here, right? So here you have F divided by N. So since friction force which is equivalent to mu S times N, then you can have here is mu S N divided by N. Then you can cut down the N over here, finally you can get mu S. So tangent S, tangent side S over here is actually the static coefficient friction. Okay, but the point is over here. Okay, okay, the point is over here. Now, as I mentioned to you that the friction force and normal force is altogether related, okay? Because the friction force need normal force and then multiply it by the coefficient friction. Now, if you understand this part over here, okay, remember what I said you, the bigger the mu force, the bigger the mu value, then you can have a bigger friction force. Now over here, okay, so in this equation you have F, okay, which is equivalent to mu S times N. So that means you have this kind of relation, okay. So that means mu s over here, okay, the coefficient static friction over here should reflect about the friction force compared to the normal force. Means that if you have a bigger friction force, okay, means that you can have a bigger value of the coefficient static friction. Okay, say for example, if you compare to rubber surface and a tile surface, the tile surface usually having like 0.3. Okay, the coefficient static friction is 0.3, but on the rubber mat or on the rubber surface, you can have exceeding those value, which is above 1. So that means the friction force is actually much more bigger compared to the normal force. Okay, so remember, this mu s has no unit, no dimension. Okay, because it actually divided by over here, then you have no unit over here. Okay. Okay, continuing for our lecture over here. Now remember, the normal force need to be perpendicular to the contact surface. That means if you have an inclined surface, that means the normal force, which is supposed to be similar as the weight. Okay, when you have inclined surface, then the weight need to be calculated along with the direction of the gravity. So that means the normal force should be much more lower compared to the weight itself. So this is some example over here. Then you can have an inclined surface like this. Okay, inclined surface where you have the angle would be theta s over here. Okay, then you can have an object over here. Okay, so the weight need to be similar direction as the gravity direction, g over here. That means this object has a mass, for example, 20 kilo. Okay, usually they will give you, okay, the mass of this crate on a inclined surface, which is m, is 20 kilo, for example. Okay, this 20 kilo need to be multiplied by the acceleration of gravity. But in this case, you have to realize that the weight itself is different. Okay, should be like this. Okay, so the direction of the weight need to be similar as the gravity direction. So the angle over here need to be similar as this one, theta s. Okay, so over here you should have the normal force and which is perpendicular to the contact surface. Okay, since this weight is straightforward like this, then you can expect that this crate or this board is over here should be moving downwards over here because of the gravity. So that's why I'm saying that the applied force can be either applied force physically and then the applied force from the gravity, from the weight. So the normal force need to be perpendicular to the contact surface, and over here, contact surface over here 90 degrees, then you can have a friction force. Now, if you understand the friction, the direction of the impending motion, for example, over here should be moving downwards like this. Okay, that is common logic. So the friction need to be opposite direction, F over here. Okay, so that is the friction force that should be applied over here, because the intended motion should be towards downwards, and the friction force resisting this motion should be going upwards over here. So of course you need to calculate this one. Okay, you need to calculate over here. So so in this case, you need to imagine this one is in flat surface like this. Okay. Okay, I know some of you can directly calculate this one. Okay, let me explain to you bit by bit. So it should be like this. And here is F. Okay. And then here should be the mass, and then here should be the weight, which is related to theta s. Okay, so right now over here you need to apply the load. Okay, to apply the load, then you need to have the normal force over here. So the normal force need to be exactly as similar as the contact surface, perpendicular to contact surface. That means you need to calculate the force over here. So the force over here should be, this is theta s, this is W, direction over here, then here should be W, weight, times cosine theta s. So you need this W cosine theta s so that you can get the normal force over here, because the normal force needs to be perpendicular to the contact surface. So over here is W cos theta s. Okay. So that means over here, if I draw some diagram, probably you can understand it much more clearly. Okay, here is the contact surface. Okay. So the weight should be like this. Weight distribution. Okay. Here is theta. And then here is theta s. Here is the normal force. And then we have this one, which is obvious. Okay. Then you can have another inclined surface like this. So it should be like this. Okay. Either one of this inclined surface or flat surface, you should have a normal force which is to be 90 degrees to the contact surface. Now, now if I erase this one, okay, it's okay for me to erase. You can go back, forth, and forward. Okay. So right now over here, okay, as I mentioned before, since I mentioned to you about equilibrium, that means you need to use the equation of equilibrium to solve the friction problem. So that means you need to have equation of equilibrium. For example, the summation of force along x-axis and y-axis, okay, which is equivalent to 0. And then another one is moment. Okay, later on we use moment so that we can calculate the, for example, the distance, the height of the force applied h, and then the distance from the center x, for example, and then we need to use this one, moment. Okay. Say for example over here, okay, you can assume this one is an x-axis and here is y-axis. Okay. So originally it's like this, okay. Originally it should be like y-axis and x-axis. So if fx is equivalent to 0, moment, force summation fx is equivalent to 0, the direction need to be like this, the positive direction. Okay. Another one is force summation along y-axis should be equivalent to 0. Here should be like this, along y-axis. Okay, so imagine like this, okay. So over here, the force summation along axis is equivalent to 0. Then long axis should be, you can have F over here, which is plus, and then here is W. The x-axis component should be towards over here, so should be minus W. Okay, so here should be along x-axis should be either sine or cosine. So in this case, x-axis should be sine. Okay, sine theta s. Okay, so sine theta s, then should be equivalent to 0. Another one over here, okay, and then minus weight cosine theta s, which is equivalent to 0. So if you simplify this equation, n is equivalent to weight cosine theta s, okay, and then you can make it into this equation, okay. For example, over here you have mu s n, because F is equivalent to coefficient friction static times normal force minus minus weight W sine theta s, which is equivalent to 0. So just replace this value into here, okay. Then you can get mu s, okay, omega cosine theta s, and then minus weight sine theta s, okay. So here get mu s, which is equivalent to W sine theta s divided by W cosine theta s, so it should be tangent theta s. So that means in inclined, okay, in inclined surface over here, the coefficient static friction should be mu s equivalent to tangent theta s. So this theta s is very important for you. Okay, another condition that you need to know, that whether the object is impending, slipping, okay, slipping, impending motion, or tipping. Tipping means tip over, okay. So this one in case for slipping occurs. Okay, this is where the object is impending slipping. Okay, so here you can have an object over here. Okay, then you have the center of gravity over here with the applied weight over here. Then you must extrapolate this line over here towards to the ground, where you have O position over here, and then you have normal force over here, and okay, then you will have this distance, okay, this distance between O and N, which is X over here, and then you have the force applied over here, P, load, applied load. Here you need to have the height H over here. Then you can have the friction force. So friction force need to be on the surface, okay, exactly on the contact surface F. Okay. Okay. Now, if slipping occurs, that means you must use the friction force equation. F is equivalent to mu s times n, and then you need to solve for x over here, okay, and all the values over here. So you need to solve x value, load value, and n using equation of equilibrium over here, okay, which is include geometry of force along x-axis, y-axis, and moment at about O over here, which is equivalent to 0. Okay. So if impending slipping, that means the X value, okay, must be in between 0 over here and then over here, oh I forget this one. This one is half of B. Okay, so remember B is the base over here, H is the height over here. So the length of this over here should be half of B. So X value over here must be lower than B over 2. Okay, but if the X value over here is negative towards here, for example, if you get X towards here, okay, so this also complying with the slipping occurs. Okay, so right now if slipping occurs, that means regardless of H over here, if you get X value over here is much more smaller compared to B over 2, then you can get slipping occurs. Okay, so X can be plus or negative value, but need to be smaller than over here. Okay, so right now, in case for the second condition, case 2, so this one is for tipping. If tipping occurs, then you need to understand that the value of X must be equivalent to half of B. Half of B means that if this distance is B, half of B. Okay, X needs to be half of B. So you need to solve normal force, like load, and the friction force F, where you should understand if tipping occurs, that means this one should be, the friction force need to be smaller or equal to the mu S times N. Previously, if tipping occurs, need to be equivalent. This one need to be smaller, okay, compared to mu S times N. So in this case, this one is in tipping, okay, tipping, in case for tipping occurs. Okay, here's some example over here. Consider this crate over here having the distance over here is 0.8 meters, and then the load applied P, which is 80 Newton, applied 30 degrees from horizontal, with height is 0.2. So if the mass of this crate is 20 kilogram, determine if the crate is in equilibrium or not. In other words, whether this crate is moving or not. So the first thing that you need to do is to draw the free body diagram. So the first step is draw FBD, free body diagram. So that means you can draw without the floor actually, and then with all the details. That means you need to draw the crate first. Okay, this is the crate. Then the applied load over here, sorry, the weight over here, weight which is equivalent to 20 kilogram times 9.81 for the acceleration, which is equivalent to 196.2 Newton. Okay, and then load applied over here. Okay, this one is important. It's important over here. 80 Newton, 30 degrees. Okay, and then don't forget the distance over here, 0.2 meter. And then extrapolate this line over here along gravity, along the center of gravity over here. Put here 0. Then you can have X over here. Okay, and then here should be the normal force N, and then don't forget lastly, which is the friction force F over here. Okay, you do not put either here if Fs or not, just put F first. Okay, so this one is the free body diagram for the friction problem. Okay, then for the step number 2, okay, you need to do the equation of equilibrium, EOE. Okay, so the first one, which is the force summation along x-axis, Fx, which is equivalent to 0. So solve it. So here you have 80 Newton times cosine 30 degrees. Okay, and then minus F that you don't know. Okay, so later on F you can replace with the mu S. Okay, so sorry, the question need to give you the sufficient detail. So in this question they will give you the coefficient static friction, which is 0.3. You need to have this value. Okay, this value, and this whole diagram is important for you to solve it. Should be equivalent to 0 over here. Continue, and then another one along y-axis. Okay, so 80 sine 30 degrees. Okay, so this one should be minus, because this one is the weight. Okay, which is in negative direction, and then plus NC, that doesn't matter. If you put crate, put NC. If human, you put H. If boy, B, and so on. Then put over here and C. Okay, and then minus. Okay, minus 196. Okay, this one came from this value. This one came from the weight value, so it should be equivalent to 0. So over here you should solve NC, which is equivalent to 236.2 Newton. Okay, and then the other equation that you need to use is the moment. Okay, so moment, you need to take moment from here. Okay, moment at about O over here. So moment MO, which is equivalent to 0. So moment take from here. Okay, so you have here is negative 80 sine 30 degrees times 0.4. Then this one, because this one should be like this. Okay, so this one is counterclockwise. Okay, counterclockwise, so it should be positive. Okay, another one is minus 80 cosine 30 degrees. Okay, times 0.2. This one, so it should be like this. There is 0.2. So clockwise will be negative. And then you have NC that you don't know, which is plus NC. Okay, times X distance that you don't know, which is equivalent to 0. So this one like this. Here is 0, but at about O. Here is NC. So this one counterclockwise, and it should be negative, positive. So you insert this value NC into here. Then you should get X value, which is X is equivalent to minus 0.00908 meter, which is approximately minus 9.08 millimeter. Okay, so F should be like this. F is equivalent to mu S N So if you insert all the value over here, okay, here you have f 0.3, okay, and then you have here is n is 236.2. Then you should get here is 69.3 Newton. Okay. So over here you have 69.3, 9.8 millimeter, 9.08 millimeter minus. So over here you can conclude okay, you can conclude over here, since the value is minus negative 9.08, so this one should be slipping. Okay, should be in slipping. Okay, impending slipping. Okay, so this value over here. Okay, so this one, sorry, this one should be 70.09. But if you calculate f from here, okay, f is equivalent to 69.3 meter. From this equation, you should notice that this value 69.3 is smaller compared to the 70.9. So remember, this one is the maximum friction force. So since the friction force over here 69.3 is much more smaller compared to F max over here 70.9, then this object or this crate should be not moving at all. Okay, this one already decided that this one, the value, it should be smaller compared to the 0.8 divided by 2. So obviously minus. So this is how for you to solve the problem for the friction. So until we continue next time, thank you very much for your time and listening, and then I will upload another video for you later on. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.